Yes. Well, sort of. A variable in an experiment is something that changes period. So if you're testing something, it's something that is you can change. So in the survey that I gave you, all of these questions are different variables. So one variable we have is age. You guys don't all have the same age, right? So that is a variable. Gender is a variable. Some of you are male, some of you are female. That's something that changes. It's a variable thing. Height, weight, shoe size, everything you can use as a variable. Now, with that said, what is, let's say, what's not a variable in this study? What do you guys all have in common? What's not variable in any of you? Yes, you guys are human. What? We're all teenagers. Yes, you're all teenagers. You're all high school students. That's not variable. Anything else? You all live in New York City, correct? So your location is pretty non-variable?
We're all in high school.
Yeah. So if I was going to test whether high school students compared to middle school students eat more meat, I couldn't test that with this group. I don't have any middle school students. What is an independent variable?
Well, the variable will not change after exposure.
Okay. So it's independent of, nothing is acting on it. It stands alone. So before we define, like in our study, what's dependent and what's independent, like what's dependent on other variables and what's independent of other variables, you have to define the cause and effect. So let's say we said in our hypothesis that a large shoe size increases your use of salt. Okay, so people with big feet would more likely eat more salt. I don't know if that's scientifically possible, but whatever. So we're going to draw a quote. This doesn't have any quotes. And so this is a result. Okay. We decided that first you have the big feet, and then you eat the salt. Okay? But we could have decided the other way. We could have said people who eat more salt somehow grow bigger feet. Okay? So in the first case, which is the independent variable? Yes. And we write independent variable as a y. No. Alejandro? Independent variable is an x or a y?
It's X.
X.
X, yeah, because your y depends on X, usually.
Yes. And so, which is the dependent variable in the first case? Oh, sorry. Okay, so this is independent, and this is dependent. What about in the other case? This is the independent. So, salt doesn't change, but the foot size does. So you see what I'm saying? Okay, so we can have another one. Yes.
So, what you were doing in that experiment, you had to basically find the same result, and then basically measure each other?
Yes. Not necessarily. You're just looking at it as a cause and effect. You can collect various amounts of salt, which is what we did. Whatever you guys wrote here, we'll just use that. And then see from there the shoe size. And it's just a cause and effect. It's just the way you look at the data. It's just the way you graph it on the plot. It's just the way you think about it. Doesn't mean you have to go out and collect. And if someone says, oh, I don't eat any salt, then you say it right on your interview. You're looking at both. You're collecting both, and then you're just mentally deciding this is how it works. Okay? But it could not work that way, then we have to reject the hypothesis.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
You count yourself?
Yeah. You didn't count. You didn't raise your hand another number.
Wait,
Yeah.
I believe exactly at 6.
Oh, that's fine. That's fine.
So what is that?
Yeah, that's not